We're hitting up heavy vocabulary, so make sure to stay on top of things like polygons and vertices. So here we have a parallelogram. Parallelogram. Notice it's got the word parallel, oh snap, in there. It's a quadrilateral. So a quadrilateral is a four-sided polygon. So we could say a special type of polygon is a quadrilateral, and a special type of quadrilateral is a parallelogram. So it's called a parallelogram because the opposite sides are parallel.
They love me.
So we can make the claim that AB is parallel to DC, right? These little arrows right here represent parallelness. And so these two sides are parallel to each other. And then we can claim that BC is parallel to AD. And so these two sides are parallel to each other. They have the double arrow to connotate that these two in particular are parallel to each other. So this is what I mean by opposite sides. Opposite is across from the other one. So if it's a parallelogram, we're instantly guaranteed that the opposite sides are parallel. So that's one fact that we know about parallelograms. Here's another fact, that if it's a quadrilateral, then the opposite sides are congruent. So not only are they parallel, but they could also be congruent. And that's if they are, if it's a parallelogram. So we can say that AB is congruent to CD, and we can say that BC is congruent to AD. All of our hard work with triangle congruency helps us to recognize and understand these ideas better. So in the previous fact, we knew that sides were parallel. Now we can make the claim that they are actually congruent. If it's a parallelogram, we also know the opposite angles are congruent. So again, if this is A, B, C, D, then this is opposite of angle C. So those two angles are congruent to each other. You can note that angle A looks like it's an acute angle, and so is angle C. And that's because they are both acute angles and they're congruent. And then we can make the claim that angle B, right, with the double arcs, is congruent to angle D with the double arcs. They both happen to be obtuse angles, and they're also congruent to each other. Now, knowing that, we also have a fourth fact we can claim.
I'm gonna put some dirt in your eye.
That if you were to pick any two angles that are next to each other, so for example, if I pick A and B, then they're supplementary, and supplementary means that they add up to equal 180 degrees.
They love me.
B and C are also consecutive, they're next to each other. Same for C and D. Same for A and D. Now again, these are angles that are next to each other. So previously we said if they're across from each other, if they're opposite angles, they are congruent. But in this case, we're saying if they're consecutive. Consecutive means they're next to each other. They're neighbors. If we find two neighbors, they're going to be equal to 180 when you add them up. This is true for all parallelograms. This fifth fact is a little trickier. So if we were to draw some diagonals,
I'm gonna put some dirt in your eye.
for example from B to D,
I'm gonna put some dirt in your eye.
and then we drew another diagonal from A to C, then we propose that these two diagonals bisect each other. Now, a lot of things can happen as a result of that. I'm going to put a point where they bisect and call it M. So what this can tell us is that BM would be congruent to MD. Because what does a bisector do? What does a bisection do? It's something that creates two equal congruent parts. And so if they bisect each other, that means they cut each other in half. These two diagonals cut each other in half, and those halves are equal to each other. So that's BM and that's MD. And if we were to look at, for example, AM and MC, then those would be congruent to each other. Now, they're not all congruent to each other. They're just congruent to the other half of itself. So we can't say that BM is congruent to AM. We can't say that. Look, look at it. This gray part is short compared to this green part, which is long. So use your eyeballs to visually inspect the diagram to kind of confirm some realities here, right? But we can definitely make the claim that BM is congruent to MD and AM is congruent to MC.
They love me.
Well, that's a lot of theory. So let's go ahead and do some practice. Problem 1, some special quadrilaterals. So let's talk about a square, right?
I'm gonna put some dirt in your eye.
Here's a square.
I'm gonna put some dirt in your eye.
Is it a polygon? Yes. Is it a quadrilateral? Well, there's 1, 2, 3, 4 sides. Yes. Is it a parallelogram? Well, I'm going to tell you that yes, it is a parallelogram. It seems that whenever we draw a square, we tend to draw a square pretty much the same, right? So we know, for example, that we know by definition that a square, all the sides are the same. So I can definitely say that this is congruent to this, and I can say that this side is congruent to this side. That's what a parallelogram asks of us, right? That the opposite sides are congruent, for example, based on the theorem. However, it's even better than that because we know that a square, all of the sides are congruent to each other. But that satisfies the condition that the sides are congruent. And I should clarify that the opposite sides are congruent, right? Well, what about the opposite angles? Is this angle congruent to this angle? Well, actually, yes, very much so. It's called a square because there's little squares right there. These are right angles. These are 90-degree angles. And actually, that's also the case for these right here. These are all 90 degrees. So it definitely satisfies that. While we're on the topic of angles, I mean, if you pick any two neighboring angles, what's 90 plus 90? Right. Okay. So that makes these supplementary. Any two pairs of neighbors add up to 180 degrees. The opposite sides are parallel to each other. And if we draw vertices, sorry, not vertices, if we draw diagonals from vertex to vertex, we'll note that these are actually congruent to each other. So this from here to here is congruent to this one. And then we have this piece is congruent to this piece. You want to call this M, we can call that M. So AM is congruent to MC and BM is congruent to MD. So diagonals bisect each other. Boom. A square is a parallelogram. So if we want to go into the details here, if we have a polygon that happens to be a quadrilateral, that happens to be a parallelogram, that happens to be a square, then this is what we're looking at. So a square is a special type of parallelogram, which is a special type of quadrilateral, which is a special type of shape called a polygon. All right, it's rectangle time. Let's prove that a rectangle is a special type of quadrilateral, which is a special... Oh, I already screwed up. That a square is a special type of parallelogram, which is a special type of quadrilateral, which is a special type of polygon. Here we go. Opposite sides, we know that a rectangle, this side, this shorter side is congruent to this shorter side, and the longer side is congruent to this longer side. So that checks out. We know that a rectangle is something interesting because it's equiangular, throwing those words out there, right? All of the angles are 90 degrees. So that means that the opposite angles are congruent to each other. Because we could pick any two of these angles that are neighbors to each other and add them up, it would equal 180 degrees. That makes these supplementary. Opposite sides are parallel, right? So this side and this side are the same distance from each other, and this side are the same distance from each other. That makes these parallel. And then finally we have the diagonals. So if I were to draw a diagonal from this vertex to this vertex, and one from this vertex to this vertex, and I put a point in the middle, then we can make the claim that these bisect each other. So from here to this midpoint is congruent to this midpoint to this other vertex, and also we get that this is congruent to this piece right here. So actually in this case they tend to all be congruent to each other. But anyway, that works out. Great.
They love me.
For your summary, if a polygon is a parallelogram, What 5 facts are true about it?